Hello everyone, myself Dr. Prashant Koli, and welcome to the last lecture of this chapter, Calculation in Analytical Chemistry. So we'll see one important topic from this chapter, that is empirical and molecular formula. So what is actually empirical formula, what is molecular formula, and what will be the probable question or problems based on this topic. Today we'll discuss all this topic in this lecture. The empirical formula of a compound gives the simplest ratio of the number of different atoms present, whereas the molecular formula gives the actual number of each different atom present in a molecule. If the formula is simplified, then it is the empirical formula. The molecular formula is commonly used and is a multiple of the empirical formula. So simply, the molecular formula is equal to n into empirical formula. So that is n is equal to molecular formula upon empirical formula. So what are the common differentiation points between these two terms, that is empirical formula and molecular formula? An empirical formula represents the simplest whole number ratio of the various atoms present in a molecule. So basically it is the whole number ratio of total atoms present in the compound, whereas the molecular formula represents the exact number of different types of atoms present in a molecule of a compound. So basically molecular formula associated with the correct number of different types of atoms present in the molecule. For example, for acetylene, the empirical formula is CH. So the two types of atoms are present in the acetylene, that is carbon and hydrogen, and that the empirical formula will be CH, whereas the molecular formula for the acetylene is, for acetylene, the molecular formula is C2H2. So that is the total number of atoms are, carbon atoms are 2, whereas the total number of hydrogen atoms are 2. So molecular formula indicating the exact number of carbon and hydrogen present into the acetylene, whereas the empirical formula is giving the whole ratio, simple whole ratio for the two atoms present in the acetylene molecule. So here the some examples are given. Here are the some examples given, that is the common differentiation between the empirical and molecular formula. For example, molecular formula for this molecule is C6H12O6, whereas the empirical formula is CH2O. Similarly, another example is given C4H10. The empirical formula is C2H5. So that is a whole number. And simultaneously for C4H8O, empirical formula is C4H8O. So these are the several examples based on the molecular formula and empirical formula. So instead of discussing these examples, we will go to solve some problem based on this topic, that how to calculate the empirical and molecular formula based on the given entities. So here is one example. An organic compound contains 26.6% of carbon, 2.22% of hydrogen, 71.18% of oxygen. Find its empirical formula. So the total percentage always equal to 100, and out of that the percentage is given for the three elements, that is carbon, hydrogen and oxygen. So here we'll make one chart to solve, to simplify this problem. We have to calculate the empirical formula for which the percentage of different elements is given in this problem. So elements are carbon, hydrogen, oxygen, and the percentage is given 26.6% for carbon, 2.22% for hydrogen, 71.18% for oxygen. So initially we'll calculate the gram atom, is that as a formula, percentage divided by atomic weight. So we know the atomic weight for carbon is 12, for hydrogen it is 1, and for oxygen the atomic weight is 16. So the percentage will be divided by the atomic weight of that each element. So the percentage is already given. That is for carbon 26.6% divided by the 12. So that is percentage divided by atomic weight of carbon. So the number is 2.21. Similarly for hydrogen, the percentage is given 2.22 and its atomic weight is 1. So 2.22 divided by 1, that is a 2.22. And for oxygen, the percentage is given 71.18. So 71.18 divided by 16, the answer is 4.44. So what is atomic ratio? We have calculated as a gram atom. Atomic ratio is equal to gram atom divided by the smallest fraction. So upon the division of percentage divided by atomic weight, the smallest fraction will be divided here in case of atomic ratio. So we see the smallest fraction from the calculation of percentage by atomic weight is 2.21. So divide this 2.21 uh, to each of these gram atom. So gram atom divided by the smallest fraction. So that is 2.22, sorry, 2.21 upon 2.21. So answer is 1. 2.22 upon 2.21, the smallest fraction. So his answer is 1.004. Now 4.44 divided by 2.21 for oxygen, the atomic ratio. The answer is 2.009. So almost we can see that the empirical formula is now the whole number for this particular calculation. For carbon it is 1, for hydrogen it is also again 1, and there are 2 oxygen. So the empirical formula of the compound is CHO2. So this is the empirical formula calculation. By doing all this calculation, we are able to calculate the empirical formula for the given compound from the given percentage. Now there is another example. An organic compound contains 38.74% of carbon, 6.7% of hydrogen, and find its empirical formula. So here you see the total percentage is always 100, but percentage of oxygen is not given here. As the compound is organic, so almost we see the organic compounds containing the common elements like carbon, hydrogen, and oxygen. Here the organic compound containing the percentage nearly 38.70% of carbon, 6.7% of hydrogen, whereas the percentage of oxygen is missing. So we'll do the summation of given percentage of carbon and hydrogen. So the total percentage for summation of carbon and hydrogen is the 38.74 plus 6.7%. The answer is 45.44 percentage. So this is the cumulative percentage of carbon and hydrogen. Now it will be get subtracted from the 100 because so total percentage is 100. To get the percentage of oxygen, we'll subtract the 45.44 percentage from the quantity 100. So the remaining percentage is equal to 100 minus 45.44. So answer is 54.56%. Oxygen will be there in the compound as the oxygen percentage was missing. So we have calculated the oxygen percentage from the given percentage of elements, that is carbon and hydrogen summation, and it was subtracted from the 100 percentage. So we'll go for the calculations. So here, as previously we have calculated the gram atom. So similarly, we'll calculate the gram atom in this problem also. So our elements are same: carbon, hydrogen, oxygen. The percentage of carbon is 38.74%. It's a gram atom will be the given weight percent divided by the atomic weight. So the given weight percent is a 38.74% divided by the atomic weight of carbon 12. The answer is a 3.22. Whereas for the hydrogen, the given percentage is 6.7%. So 6.7% divided by the atomic weight of hydrogen is 1. So the gram atom is the 6.7. Whereas for oxygen, 54.56% we have calculated. So 54.56 divided by 16, that is the atomic weight of oxygen. The answer is 3.41. Now the 3 gram atom quantities we have calculated. So out of that, we have to search that which quantity has a less fraction. So smallest fraction we have calculated here for the carbon, which is a 3.22. So to calculate the atomic ratio, the smallest fraction will be divided for each gram atom. So atomic ratio is equal to gram atom divided by the smallest fraction. So here the gram atom calculated for each element, and that will be divided by the smallest fraction to get the atomic ratio. So 3.22 divided by 3.22, the answer is 1. 6.7 upon 3.22, the answer is 2.08. 3.41 upon 3.22, the answer is 1.01. So for carbon, hydrogen, oxygen, the atomic ratio for carbon is 1, for hydrogen is 2, and for oxygen is 1. So again, the empirical formula of the compound is CH2O. So that is the empirical formula. So based on the atomic percentage, we are able to calculate the empirical formula for any given compound. So these are the some calculation to calculate the empirical formula. Now empirical formula and molecular formula has another type of problem. For example, we can also calculate the molecular formula if the empirical formula and molecular weight is given. So what is the formula and how to calculate? For example, the problem number 3, the empirical formula of the compound is given CH2O, whereas its a molecular weight is also given 90. Then find its a molecular formula. So empirical formula and weight is given, then we are able to calculate the molecular formula. So what is the solution? So empirical formula weight we have to calculate by adding the atomic weight of each element present in the compound. So empirical formula weight is equal to the compound is CH2O. So we'll add the atomic weight of carbon, hydrogen, and oxygen. For carbon it is 12, for hydrogen it is 2, for oxygen it is 16. The overall calculation is a 30. So empirical formula weight is 30. Now we will calculate the n. The small n has a formula, molecular formula weight upon empirical formula weight. So molecular formula weight is already given, that is molecular weight, which is 90, and empirical formula weight is the summation of all the atomic weight of the element given in a compound. So the empirical formula weight we have calculated as a 30. So 90 upon 30, the n value is a 3. Now what is molecular formula? So molecular formula is n into empirical formula. So we have calculated n here, that n is a simply molecular formula weight upon empirical formula weight. From this formula we have calculated the value of n. So molecular formula is equal to n into empirical formula. So empirical formula is already given in the problem. So 3 into CH2O. So 3 multiplied to each element, the molecular formula is C3H6 and O3. The molecular formula of the compound will be C3H6O3. So this is the way to calculate the molecular formula. The empirical formula and molecular weight is given. So thank you very much for watching this video, and by watching this video you are able to calculate the empirical formula as well as the molecular formula and the calculation based on the empirical and molecular formula. Thank you very much.